All right, so get this. We're diving into the world of, futuristic energy sources. And the star of the show is, wait for it, tape.
Tape.
Yep. That same roll sitting in your junk drawer just might hold the key to, like, powering our future. Pretty wild, huh?
Sounds a little crazy, but, researchers are making some serious headway with triboelectric nanogenerators.
Try saying that 3 times fast.
TNC. For sure. Okay, much better.
So, TINs.
These devices can convert mechanical energy, like from simple movements into electricity.
Okay, so I think we've all experienced static electricity like rubbing a balloon on your hair, right? But how do they turn that into something that can actually, like, power a device?
It all boils down to the materials, really.
Mm-hmm.
Researchers at the University of Alabama, Huntsville, they found that, the combination of polypropylene,
Polypropylene.
which is what most tape backing is made of,
Okay.
and acrylic adhesive creates a really potent, triboelectric effect.
So it's like you need a very particular combo, not just any old tape will do.
Exactly, yeah. And it all comes down to something called the triboelectric series.
The what?
The triboelectric series. It's this, it's basically a ranking of materials based on how readily they gain or lose electrons when they come into contact with other materials.
Okay.
Polypropylene and acrylic adhesive. They're pretty far apart on this series, which means that when they rub together, you get a big charge imbalance.
Interesting. So they kind of cracked the code of the magic combo, so to speak.
Yeah.
But how does that actually translate to, like, usable power?
All right. So picture this. You have a piece of heavy-duty tape.
Okay.
Every time you stick it to something and peel it off, you're basically generating a tiny spark.
Okay.
Now imagine doing that like hundreds or even thousands of times per second.
Okay, I can see where we're going with this, but wouldn't that take, like, a lot of force? I mean, heavy-duty tape is no joke.
Yeah, you're right. And that was a limitation with their initial prototype. They were using, double-sided tape, which was really tough to separate.
Right.
But they found a pretty clever workaround.
Okay, I'm all ears.
They switched to single-sided heavy-duty tape, generating power from the interaction between the adhesive layer and the backing on the same piece of tape.
So you don't have to peel the 2 sides apart.
Right. So, it's much faster, easier sticking and unsticking.
Mm-hmm.
And to really ramp things up, they use a vibrating plate that basically does all the sticking and unsticking automatically, rapidly creating those electricity-generating moments.
Oh, wow. So it's like a tiny tape-powered engine.
Kind of, yeah.
So I gotta ask, how much power are we actually talking about?
The new design generates a peak power output of 53 milliwatts.
53 milliwatts.
Hmm.
To be honest, it doesn't sound like a lot.
Yeah.
Could that actually power anything, useful?
I get why you might think that. I mean, we're talking about harvesting energy from what is, a pretty small low-power source.
Mm-hmm.
But 53 milliwatts is actually pretty impressive in the world of energy harvesting. It's enough to light up, like, over 350 LED lights or even power a small laser pointer.
Okay, now that's pretty cool. Suddenly that roll of tape in my drawer is looking a lot more interesting. But let's talk about practical applications. Where could we actually use this technology?
Well, the really cool thing is, it's pretty versatile. The researchers have already developed 2 really interesting sensor prototypes.
Oh, wow. Okay.
One's a wearable biosensor. It can, detect arm movements.
Okay.
And the other is an acoustic sensor that picks up sound waves.
So we're not just talking about generating power. This tape can also act as a sensor.
Yeah, pretty neat, right?
That's pretty cool. How does that even work?
It basically all comes down to converting mechanical energy into electrical signals.
Okay.
So think about the wearable sensor. When your arm moves, it makes those tape layers stick and unstick, and that generates like this tiny little electrical current.
Oh.
And that current can then be, measured and interpreted to track your movement.
Interesting. But wouldn't that mean, like, the power output would be kind of all over the place?
Yeah.
Depending on the movement?
Exactly. And that's a key difference between this technology and, something like a traditional battery.
Right.
The battery gives you this, like, constant output.
Right.
But with TENGs, the amount of energy you get is directly related to the mechanical energy you put in.
Okay.
More movement, more power.
I see. So you're basically capturing these, like, tiny bursts of energy created by everyday actions. It's kind of a whole different way to think about, like, powering devices.
Yeah, for sure. And think about all the potential applications.
Yeah.
You could have fitness trackers that are, powered by your own steps, or heart rate, environmental monitors that generate energy from wind or vibrations. You could even have medical implants that draw power from just the natural movements of your body.
That's incredible. Yeah, I can definitely see the appeal of self-powered devices.
Yeah.
But I'm curious, how does this technology compare to like other energy harvesting methods, like solar power, for example?
Okay.
I mean, solar panels are getting pretty efficient these days.
That's a great question.
Yeah.
It really comes down to the specific application you have in mind. Solar power is awesome for, large-scale energy production or devices that are, out in the sun all the time. But what about devices that are like worn on the body or in places where sunlight is limited?
Yeah.
That's where TENGs could really, make a difference. They can capture energy from sources that people often don't even think about. Vibrations, pressure, even friction.
So it's not about like replacing solar altogether.
No.
It's about finding the right tool for the job, so to speak.
Exactly.
It sounds like TENGs open up all these new ways to like power devices. It's a whole new approach.
Exactly. And the acoustic sensor we were talking about earlier, that's another great example.
Okay. Yeah.
It works by converting sound waves into vibrations, which then activate the TEN.
Oh.
So, you could have self-powered microphones, noise-canceling headphones, even sound-activated security systems.
Wow. I never even considered that. We really are surrounded by all this like subtle energy and we don't even think about it.
Yeah.
All of a sudden, all those everyday sounds and movements, it's like they become potential power sources.
And that's what makes this research so cool. It makes you rethink how you see energy. We're so used to thinking about energy as like, big power plants and electrical grids.
Right.
But what if we could use all those smaller everyday sources,
It's almost like we're like shifting from this idea of like centralized power to a more like spread out, decentralized model.
Exactly. And that could have huge implications for, everything. Personal electronics, the way we design our cities, infrastructure. Think about it.
It's amazing, right? You have this seemingly simple technology, but it could lead to such like fundamental changes. It really shows the power of scientific discovery and, just being creative and innovative.
Totally.
But, let's not forget about the tape itself.
Yeah.
We're talking about something that's designed to be disposable, right?
Yeah.
It's everywhere. It's cheap. Could there be, I don't know, any downsides to using it this way?
That's a really good point. While the abundance and the affordability of tape, those are definitely big pluses.
Right.
We have to think about the environmental impacts, right? The adhesives in some tapes.
Yeah.
They have some pretty nasty chemicals in them.
Right.
And if we're going to be, using all this tape for TENGs, we need to figure out how to dispose of it properly,
So it's not a perfect solution. But it seems like, we could probably figure out these challenges with a little more research. Like, could we make biodegradable tapes or adhesives?
Yeah.
Could we recycle the materials from the TENG?
Absolutely. And that's where collaboration is key,
Yeah.
Scientists, engineers, material experts, they all need to work together. We've got to figure out how to use this technology and make sure we're not harming the planet in the process.
Right. It seems like we're just getting started with this whole field, really.
Yeah.
But the possibilities are like so exciting. It's crazy to think, right? Something as basic as like tape could lead to a whole new, way of harvesting energy.
It really is.
Yeah.
And it just shows you, the power of looking at things, even everyday stuff, with fresh eyes.
Yeah. Like, I keep thinking about the medical implants. Imagine, powering a pacemaker with energy from the body's own movement.
Exactly.
Yeah.
No more batteries.
Yeah.
They could completely change how we think about, implantable medical devices.
The possibilities, like even just in healthcare, it's mind-blowing.
It really is. Smaller devices that last longer, devices that are, safer for the body.
Yeah.
It could change everything.
And think about the bigger picture, right?
Yeah.
If we can tap into all this, unused energy that's all around us, we could create a whole new energy system. It could be way more sustainable.
Totally.
Imagine cities powered by the vibrations of traffic.
Or buildings that generate energy from the wind and rain.
Yeah. Imagine wearing clothes that charge your phone just from you walking around.
Exactly. And this research, it shows us how science, technology, and how we live, they're all connected. The answers to the big problems we face, they could be hiding in plain sight.
It's a good reminder, right? We need to be more curious, look at our world in new ways. So to everyone listening, what hidden energy sources are you surrounded by right now? Think about it. Those everyday objects, those everyday things you do they have like some hidden potential? Maybe the next big energy breakthrough is just waiting to be discovered. It might just be a sticky spark away, and who knows, it might come from the most unexpected place.